Hello everyone, I am Suchita Moril. Welcome you all in the video lecture on the topic Difference Equation with Constant Coefficient Part 3. In Part 1, we discussed PI case 1. That means whenever the right hand side is a to the power n. In Part 2, we discussed PI case 2. Whenever the right hand side of the equation is cos kn or sin kn. Now, in this Part 3, we discuss pi case 3 when the right hand side of the equation is n to the power p, that means in terms of polynomial. Then we write down this f of e as f of 1 plus delta by substituting the value of e, and then we form here 1 by taking lowest term common and write down this function of 1 plus delta in the numerator with negative index into n to the power p. Now express n to the power p in factorial notation and then expand by using binomial in ascending power or delta up to the term delta to the power p and operate this n to the power p with each term of the expansion and find out the required pi. Now we discuss problem. Here this given equation we first convert in terms of E and then solution of this equation 1 is yn equal to Cf plus Pi. Now for auxiliary equation here E equal to m, therefore m cube minus 5m square plus 3m plus 9 equal to 0. The roots are these. Now here for minus 1 apply case 1 and for 3 apply case number 2 for writing CF. Now here right hand side is 2 to the power n, therefore we separate the term because here we apply case 1 by substituting e equal to 2. But for 3n this is polynomial in terms of n, therefore we apply case number 3. Now when we substituting e equal to 2 we get the denominator term equal to 3, which is not equal to 0, therefore 1 by 3 to the power n, which is the required value of pi for first term. Now we solve second term. Now substitute e equal to 1 plus delta and then expand the terms, combine the terms, and then taking lowest term common, that means 8 common from the denominator, we get this value. Then write down this value in the numerator with negative index, expand by using binomial. Now here 1 minus of this term and here this suppose x value, then here x square and so on. Then this first term as it is we continue. Now here n to the we convert this into factorial notation, n equal to n to the power 1 factorial, therefore we consider term up to delta only. Therefore here 1 plus, because minus minus become plus delta by 2 n to the power 1 factorial. All other derivatives or delta values are 0 for n to the power 1 factorial. Now separate the terms, here 1 into this value, then delta by 2 into n to the power 1 factorial. Now its derivative term, this delta is equivalent to differential operator when we write down in factorial notation. Therefore derivative of this n to the power 1 factorial is 1 and this 1 by 2 is constant. Now again convert this n to the power 1 factorial in terms of n and then which is the required pi. Lastly, write down complete solution yn equal to, this is CF value, first part, and this is pi value. Now, we discuss second problem. Here, given equation convert in terms of E, then solution is given by CF plus pi. We write down auxiliary equation. The roots are imaginary in the form of alpha plus minus I beta. Now for this we have to find out r and theta value. R and theta. Here this alpha under root of alpha square plus beta square. Alpha is minus 1 by 2 and beta is root 3 by 2. Now substitute the value, we get 1 value. Theta equal to tan inverse of beta by alpha, therefore tan inverse of minus root 3, that means we substitute 2 by 3. Then We write down the CF r to the power n C1 cos n theta plus C2 sin n theta. Now 1 upon function of e into this is the polynomial in terms of n, therefore we apply case number 3 for finding Pi. Now substitute E equal to 1 plus delta and simplify this taking lowest term common. Now here lowest term is 3, therefore 3 taking outside. Remaining term we have to write down in the numerator with negative index, expand by using binomial, and then combine the terms of delta square. Now here highest power is of polynomial is 2. Therefore, we consider term of 2 delta square. If we expand its third term here, delta square by 3 plus delta whole square, then we get this type of expansion. But here we cannot consider this first value and second value because its derivative term equal to 0. Therefore, we consider only delta square here. Now combine the terms of delta square here delta and constant term, and here convert n square plus n plus 1 in factorial notation. Now factorial notations equal to this, therefore separate the terms, operate by each term, and then if delta is there, then first derivative and delta square, that means second derivative. Now, lastly, combine the terms and substitute the value of delta n to the power 2 factorial. Its value is n into n minus 1. That means n square minus of n. And this is the required Pi. Lastly, write down complete solution CF plus Pi. Another example here, apply same method. Here, given equation, we write down this equation in terms of E, then complete solution is CF plus Pi, auxiliary equation, the roots are real and different, therefore apply case 1 for writing CF. Pi equal to, first we write down the value, substitute the value of E, then 1 plus delta, then combine the terms of delta square, delta and constant value taking lowest term common, that means 12 common, then remaining term we have to write down in the numerator with negative index, expand by using binomial, convert the right hand side, that means n in terms of factorial notation, and we here n to the power 1 factorial, therefore we consider term up to delta only, operate by each term, separate the terms here, derivative of this value, that means 1, 7 by 12 is the constant value. Lastly, n to the power 1 factorial equal to n converts in terms of algebraic terms. And lastly, write down complete solution CF plus Pi. In this way, we solve the problems of this Pi third case. Are the practice problems. Thank you for watching this video.